Well, this presentation is about try to describe some findings we discovered during a measuring campaign we performed in a chip. This was an important measuring campaign because it took around 2 months. I think a little more actually, more than 2 months. So we were able to collect a lot of data from that measuring campaign. We performed uh, we uh, we had three Elgas sensor boxes in three different locations inside the ship. One was in the wheelhouse, the other one in the kitchen, a small kitchen, and the third one in the engine room. Um, okay, so let's start about the parameters we obtained. First, let's go through the wheelhouse. This was the parameters we obtained. Our first impression is that there is a lot of peaks and fluctuations, and one could say that maybe these peaks match each other because sometimes it's possible to see they are very they are occurring during the same moment. But using this visualization is a little bit complicated to analyze. One thing we have to say about the measurements here is that the CO, we have one of the problems Olivier already mentioned with the sensor, that the measurements were so high, the they reached the saturation point, so we couldn't obtain the peaks from the CO sensor. But okay, we are able to say that the environment is changing here, but we would like to see if there is some relation between the parameters. For that reason, we performed a event detection analysis where we corrected the baseline of each single environmental parameter, and then we obtained the maximum values above certain concentration value. We did this manually for each parameter individually, and so here in this slide you can see how they look after the finding these peaks. It's still very complicated to say if there is some relation between the peaks. That's the reason why we changed the way we visualize this graph by using this type of graph. Then here we were able to see that there are some relations. We divided these events in clusters, and I tried to identify this cluster in three different types. The type number one is the cluster that where the events are similar between a few parameters during a brief time. Cluster number two are brief moments where all the parameters had events that matched together, and cluster number three are it's a special case of two parameters that they were having peaks matching for a long period of time. That is the case of temperature of ozone. So this was a nice analysis because we were able to see that there is some relation between these peaks somehow. We also wanted to see if by this visualization you will see that these peaks are matching, but we don't know where these events happening and for how long they are happening. So we also made an analysis using carpet plots, and one of the things we realized is all of them, in the case of the wheelhouse, has certain relation, or the events have certain relation with the temperature. The problem with the carpet plots I obtained here is that we average each pixel, so the resolution of the data is reduced, and we collected this data every 3 minutes, and in the carpet plot we obtained the data, we showed the data every hour. So this information within an hour is average, and this is the information we obtain here. So the peaks are somehow are not that exact, but we can say where are the moments where the maximum values at what time of the day these maximum values were happening. For example, for the temperature and the TVOC, we see that many of these maximum values were occurring during the same day, although not exactly at the same time during the day. And also there are some peaks from also some maximum values from temperature that are not matching with any TVOC parameter. We performed the same analysis for other gases, and we were able to see that there were a lot of situations where these gases were having maximum values the same days of the temperature were having also the maximum values. So the CO2 that is very related to human presence is also having maximum value during those days. And in the case of another thing to say is that the temperature was having the highest values from 7 a.m. more or less to 24 hours. So this is something that was also curious. And we obtain also for the ozone the same correlation. We did the same analysis, a similar analysis for the kitchen, and in the kitchen we also saw a lot of peaks. And in the case of the temperature, we don't see this day and night variation from temperature, but we think that maybe it's possible that temperature at the difference of the wheelhouse, the kitchen doesn't have that much exposure to sunlight as in the wheelhouse, and at the same time the kitchen has another sources of temperature. So this type of cyclic changes, variations, is not that easy, or it's not possible to see for the kitchen. At the same time, we see that the CO were having the lowest value at these specific times in this marking the squares, but at the same time, the peaks we see here in the graph below were occurring during the end or at the beginning of the day or the week. So this might have certain relation with human presence somehow. Here's the CO2 that is related to human presence. We see that the maximum values are occurring within these squares that are shown in the graph. The PM10 also is interesting to see that the PM10, the highest value, are occurring during the same time that it seems that there is human presence inside the kitchen. Also, the ozone that is also having maximum value during those times. So in the engine room, we had a problem during the measuring campaign. We were not able to obtain all the data from the full period, but still we were able to notice some interesting things. For example, the CO concentration is higher in the wheelhouse compared to the engine room, and this is interesting. And in the case of the TVOC, we have the maximum values are higher in the wheelhouse than in the engine room, but the average values is lower in the wheelhouse. So we also perform a risk analysis between these three different locations. For example, in the wheelhouse, we see that the concentrations are quite low compared to the occupational thresholds. And the parameter having a higher risk is the CO. That is the one we have a problem with the saturation. And the overall risk is marking that the PMs, the moments where the PM have the highest values, were the moments of highest risk. With the kitchen, we have a similar situation, but the CO is lower in this case. And in the case of the engine room, we also obtain low values compared to the occupational thresholds. If we compare the three locations by using the overall risk, we can see that the wheelhouse had probably the higher values of risk, although in the kitchen, the moment with the higher moments of risk was higher, that was more frequent. And it's interesting to see that in the three locations, this higher moment of risk were occurring more or less at the same time. with the same frequency. So it seems to these moments of higher risk were related each other. So this might be interesting also to find out what is this the reason why this is happening. So the conclusions for this measuring campaign is that we are able to see events using our visualization methods. We are able to say that these events are correlated because all these peaks are matching together, and it seems as logical that they're coming from the same pollution source. We can say also that there are more exhaust gases in the kitchen than in the engine room, and the CO in the engine room is lower than the wheelhouse. So these are the conclusions we have for this presentation.